Welcome everyone. Thank you for joining us today for the webinar. My name is Ankit Patel, working as a head of department in aeronautical engineering, CITDS at Paris University. Today we are presenting a webinar titled as Introduction to Vibration Monitoring, presented by Professor Tejas Gotikar from SUIT Vasad. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them to my number 9978225359. I repeat again, 9978225359. I will bring them up during the presentation, and we will also have a time for the question at the end. Now, without a further ado, we will turn the time over to the Professor Tejas Gotikar sir. Our presenter today is the Assistant Professor in Mechanical Engineering at SUIT Vasad with a great knowledge and expertise on the subject, having 13 years of teaching experience. Tejas sir, hand over to you.
Okay. Thank you so much. Okay, so as I know, most of the students are from diploma engineering. Okay, so today's topic it's about introduction to vibration monitoring. So before going on to the vibration monitoring, we will also see some of the fundamentals or some introduction about the vibration. Okay, hope I'm audible. Yes, sir. Thank you, sir.
Yes,
Am I audible?
Yes, sir. You are audible.
Okay. Yes. So this is the outline. So first we'll go over the introduction part of a vibration. Then we'll see what is mechanical vibration. Okay. Then we will go over condition-based maintenance. Okay. It is like why we are going for vibration monitoring. Okay. The answer for this question is in this condition-based monitoring. Okay. Just a minute. Yes. So why we are going for vibration monitoring? It is because of this condition-based maintenance system. Okay. And then we'll go over the vibration monitoring, and if time permits, we'll go over vibration measuring instruments. Okay. It's a very small topic. Okay. It will go over a few of the instruments quickly. Okay. So this will be the outline. Okay. So before starting the vibration, okay, so if we go over historical background, okay, so it's like almost 6,000 years back. Okay, it is like 400 BC, means before this like year starts. It's before that 4,000 BC, means around like 6,000 years back. The study of vibration started. Okay, still it was not on the scientific basis. Okay, it was just like trial and error. Okay, and the useful application, it started by the musicians. Okay, so they started using the law of vibration. Again, it's not on the scientific basis, but it's this they know like there is like what is vibration and how we can use it. Okay, so for sound production, they started using the vibration. Okay, after that they started experimenting with that vibration. Means what they done, they like change the diameter of a string. Okay, if you see here we have a musical instrument. Okay, so they started using the string with a different diameter. So a thin diameter wire, it will give like low pitch sound. If it's a large diameter, it will give you high low pitch sound, right? So based on that, they started experimenting with the different musical instruments. Okay, and if you see like most of the instruments, right now what we have, those are like modern version. Okay, but if you see like very old instruments, even if we consider like a harmonium or a guitar, it's an old type. Okay, so all those are from the Egypt. Okay, and this is like one very old instrument that is known as harp. Okay, that again works on the principle of vibration. Okay, and when it started, like around 2500 years back. Okay, so Pythagoras, we must have heard the name, right? He started investigating the different musical instruments, and he started the scientific base for the vibration. So he was the first person who studied vibration on the scientific basis. Okay, and if you see, like in our day-to-day life, like we are using vibration. Okay, so okay, that particular thing we will see afterwards. Okay, so now first of all, what is vibration? Okay, so it's a vibration, it's a motion that repeats after an interval of time. Okay, again, there are like two types of vibration. It may be a periodic or it may be a random. Okay, so periodic means when it repeats at a regular interval. Okay, means if for one oscillation it takes 1 second, so for second also it will take one oscillation. So for third also it will take 1 second. Sorry. Okay, so that is a periodic motion. Okay, so it takes a same interval. And if it is, if time is not is not same, so in that case we can say a random vibration. Okay, so in case of a vibration because of wind, okay, vibration because of wind, it's a random vibration because that depends upon the wind speed, and that is not constant, right? So those are the two main types of vibration. Okay, if we consider a simple pendulum, here it is a simple pendulum. Okay, the time period is same for each cycle. Okay, and whenever the time period is same, we call it an oscillation. Okay, we call it an oscillation. And if time period is not same, we will call it vibration. Okay, it's oscillation, it's a type of vibration. Okay, oscillation, it's a type of vibration, but when time period is constant, same, we will call it an oscillation. Okay, so how vibration occurs? Okay, so it's because of small molecules in the body. Okay, this starts vibrating, and the kinetic energy of one molecule, it is passed to the another, and it's like a chain reaction. Okay, and because of that, the body displays from the equilibrium position. Okay, and because of that, the system vibrates. Okay, and in this vibration, what happens? Here the potential energy and kinetic energy, it is transferred in one into the another. If we consider this simple pendulum, okay, if we bring this pendulum at position A, okay, so at this position it will have the highest potential energy, and as you leave it like oscillate on its own from this point A, it will reach at point B. At this point it will have minimum potential energy but maximum kinetic energy, right? So here this potential energy, it is converted into the kinetic energy from B to C. Again, this kinetic energy, it will be converted into the potential energy, and this particular cycle keeps on. Okay, so okay, and if we consider in the engineering terms, okay, it causes like many different types of failures. Okay, and it is like because of vibration we may have excessive stress, we may have excessive amplitude. Okay, or we may also have material fatigue. Fatigue means over a period of time. Okay, it's over a period of time. If you apply the stress on the system, still it is below its critical level, the material may fail. Okay, so that comes under this fatigue failure. Okay, so these are few of the effects of vibration. Okay, and if we see few of the examples, so that there is like one example here. It is like Tacoma Bridge. Okay, even during school days, like we have studied, right? Like you cannot march past on a bridge What is the reason? The reason is it will generate resonance. Okay, it will generate resonance. What is resonance? That we'll see afterwards. Okay, so let's see one small video here. Okay, so here they had like this one particular year. Okay, it was newly inaugurated bridge, and at the time the wind speed was around like 40 kilometers. Okay, the wind speed was around 40 kilometers. So it was not much, but what happened? The natural frequency of the bridge and the frequency of that wind, okay, they match with each other. And you can see here the bridge started vibrating, okay, and it collapsed. Okay, as such, so there was no as such like much load on the bridge. But here what happened? It is the like frequency, like natural frequency of a bridge. It matched with the wind natural frequency, and the bridge collapsed. That was like one example. Okay, so here let's go over one another video that is about helicopter blades. Okay. Okay, here you can see this like the blade, it is vibrating. Okay, and it ultimately results into the failure. Okay, it was on the ground, so it didn't had any casualty. But if the same thing happens while it is flying, or even in case of airplane, okay, engine shaft, okay, if it started vibrating, okay, engine rotor, if starts vibrating, okay, so the results might be very different, right? So this is the reason like we are going for vibration monitoring, okay, because this is not a one day effect. Just a minute. Right, so this is not a one day effect. Like this particular thing started with a small vibration, and over a period of time this vibration increases. Okay, so if we are able to detect the vibration well in advance, we can eliminate the failures, right? So this is the reason behind going over the vibration monitoring. Okay, so now whenever we go for any system analysis, okay, whenever we go for system analysis, what we need a equation of a system. Okay, we call it a mathematical model. We call it mathematical model of a system. Okay, and if you see here, we have a car. Okay, if you want to write down the equation of this particular car directly, we cannot write down, right? We cannot put it in the form of equation. So what we need to put it in the equivalent spring mass system. Okay, and whenever we want the mathematical model of for a vibration purpose, we need to convert it into spring mass damper system. Okay, so here if you see, we have a car that you can see here. This is a mass of a car. Here we have the spring and damping of a suspension. Then here the another mass that is for wheel and wheel drive, and another at the last we have the spring that is a stiffness of a tire. Okay, so this way we can figure out what is the system model for our car. Okay, and the same type of equation we can figure out for different types of system. Okay, but it is not so easy. It is not so easy for all the systems. Okay, for car we can figure out, but It is not the same for all the system. Let's say in a, if we want to find out in aeroplane, okay, so we cannot like simply put it like mass, spring and damper. Okay, it's not possible. Even in case of any machine, okay, so it is not possible to like put it in the spring mass damper system. Okay, so for some of the system, as here it is mentioned, some of the system it may be clearly visible to like put it in the form of spring mass system. Okay, but in most of the system it is not so easy to figure out the spring mass damper system. Okay. So now if we see the effects of vibration, okay, so it's not like always vibration is harmful. We are using vibration for our good, right? So if we see like useful effects of the vibration, okay, so here like vibration hammer we are using, it is to break the roads or concrete structure. Okay, so we are using this hammer, it's called jackhammer. Okay, also we have like vibration testing machines or ultrasonic cleaning, or even in our mobile phones, right, we have a vibrator, right, so vibration mode. Apart from that, we have massager or vibro conveyors, right, so all those are the applications of vibration, right, so we can use those vibration for useful work. Or all the musical instruments, right, they are also working on the principle of vibration. But now whenever it is not desired, the application where the vibration is not desired, okay, so what will start, like it will start with it will start creating some noise. Okay, because of that vibration we may have wear in a system. Okay, because of wear there may be fatigue, and ultimately it will be a destruction or a failure of a system. Okay, so there are like many harmful effects as well of a vibration. Okay, and so this is the again reason behind going over the vibration monitoring. Okay, now if we see in our life where we are using vibration, okay, so our heart beats, right, so again that's nothing but a vibration. Our lung pumps oxygen in our body, or we are able to hear. Why? Because our eardrums vibrates, right, our eardrum vibrate and we are able to hear. Vibration makes us snore or light waves. Because of that we are able to see, or sound waves that allow us to hear. And because of the oscillation of our leg we are able to walk. Okay, so like everywhere we are using vibration. Okay, wherever we have the waves, it's a vibration. Okay, but in some of the cases we are even not able to identify like there is a vibration. Okay, okay, so now we will go over what is mechanical vibration. Okay, now we will see this in terms of mechanical system. Okay, so before going into the vibration, let's go over a few of the definitions. Okay, you must be knowing this, but still let's go over. Okay, and whenever we see the vibration chart, on the x-axis, horizontal axis, we have time. On vertical axis, we have the displacement. Okay, and in most of the cases, if it is a regular vibration, normal vibration, which repeats at a regular interval, so we will have in a sinusoidal form, or we call it simple harmonic motion. Okay, simple harmonic motion means we can put it in the form of sine or cosine, any trigonometric equation. Okay, so if we are able to do that, it's a simple harmonic motion. Okay, So now, first of all, what is time period? So it's a time required for one oscillation. Okay, so from here, the oscillation starts and it completes in 1 second. Okay, so here the time period is 1 second. Okay, then what is amplitude? So amplitude means from mean position. Okay, so this is the regular position. Let's say it's a simple pendulum. Okay, so it oscillates on one side, it oscillates on the opposite side. Okay, so on one side, what is the maximum amplitude it is traveling? So that is nothing but the amplitude of a vibration. Then frequency. What is frequency? So in unit time, how many oscillations do we have? Okay, so it's a number of cycles per unit time. So here in 1 second, we have one oscillation. So the frequency is 1. It's 1 hertz or 1/second. Okay, now the natural frequency. Okay, so first of all, it is the frequency of a free vibration of a system. Okay, now what is free vibration? Okay, again here, first of all, we have seen the type of vibration where we have a random and a periodic vibration, right? Okay, next we have a damped and undamped system, or it's a damped and free. Okay, so it's a, again, we will see that in the classification. Okay, so let's keep it at the, for that particular slide, this natural frequency. Okay, at that time we'll again discuss. And the next one is resonance. Okay, so resonance means whenever the frequency of force, okay, that force that is exerted on a system, okay, so the frequency of a force and natural frequency both matches, in that case we call it the resonance. Okay, so the vibration of a system when the frequency of external force is equal to the natural frequency of the system, right? So when both the frequencies matches, we have the resonance in the system. Okay, so here we have the classification. Okay, so now in classification, what we have, it's a free and forced vibration. Okay, so the vibration, we can call it, it's a free vibration and forced vibration. Okay, so now what is free vibration? So when there is no external force acting on the system, okay, when there is no external force acting on the system, we call it free vibration. Okay, now in case of simple pendulum, what we are doing, we are displacing the pendulum. Okay, we are displacing the pendulum and then we are letting it oscillate on its own, right? After that, we are not applying any force. Afterwards, we are not applying any type of force on the pendulum. Okay, so we can say it's a simple or it's a free vibration. Okay, and the frequency of that, we call it natural frequency. Okay, we call it natural frequency. And what is force vibration? So when there is like continuous force, when we need to apply, okay, we need to apply a continuous force. So in that case, that is a forced vibration. Okay, in case of, let's say again, a simple pendulum, at each cycle, if we apply one small force, okay, if we apply one small force, so then that's a forced vibration. That is not a free vibration. Okay, so at each cycle, after each cycle, we are applying some force. So that's a forced vibration. Okay, and again, we can subclassify this in the form of undamped and damped vibration. Okay, what is undamped and damped vibration? Okay, in nature, there is no undamped system. Okay, it's not possible to have like undamped system in real. Okay, in theory, we can write down, it's like there is no damping in the system, so it's an undamped system. But in practice, it's not possible to have this undamped system. Okay, all the systems are damped. Okay, even if you consider simple pendulum, okay, as it oscillates, after some time it will come to equilibrium, right? It will stop oscillating. We are not applying any force, but still the oscillations will decay and it will stop after some time, right? So what is the reason behind that? A friction, air drag, right? That is the reason behind the decay in vibration, and that is nothing but a damping. Okay, that is a natural damping on the system. Okay, so damping is always there. So in practice, we cannot have undamped system. Okay, we will always have a damped system. Okay, damping means what? Which absorbs the vibration. Okay, damping absorbs the vibration. Okay, now one thing let's study about, that is in spring mass damper system. Okay, what is the function of spring? What is the function of damper? Okay, what is the function of spring? What is the function of damper? Okay, it's a spring mass system. So mass we should have, or without mass it's not possible to have a system, right? So mass by default we will have. Now what about spring and damper? Okay, let's say damper, the function of damper is to absorb the vibration. Okay, so can't we only have a damper? Because the damper, it will just absorb all the vibrations. But what is the function of spring? Here I have one figure right here. So if we have mass, here it's a spring, here it's a damper. Okay, so because of damper, we will have less amount of vibrations. Okay, but because of spring, what will happen? The system will come back to its equilibrium position. Otherwise, if we don't have the this spring, okay, in that case, this mass, it won't come back to its equilibrium position. Okay, so mass will stay on its displayed position. This damper, it will absorb all the vibrations, but system needs to come back to its equilibrium position. That won't happen. Okay, so this is like classification, and it based on the type of motion. So it's a in spring mass system. Okay, it's a longitudinal vibration, or in case of a pendulum, it's a transverse vibration, right? And in case of a rotor, let's say we have a shaft, and at the end of the shaft we have one rotor. So if we rotate this disc that is attached here, okay, so that's a torsional vibration. Okay, so this is like classification of vibration. Okay, now what causes the vibration? What causes the vibration? So unbalanced mass distribution means the density is not uniform throughout the system. If density is not uniform throughout the system, so that will cause unbalanced mass distribution, and that will ultimately result in the vibration. Or unbalanced force distribution means in one direction there is more force compared to the other direction. So again, that will result in vibration. Or misalignment, when shafts are not aligned properly. Okay, the axes, they are not in same line, or they are at some different angle. Okay, one shaft is in horizontal, the another shaft has to be in the same direction, but if it is at some another angle, so that is misalignment. Or wear and tear. So that is, these are like few of the causes behind vibration. Okay, so if we figure out what could happen, so it's unbalancing, misalignment, looseness of parts, defective bearings, resonance, eccentricity, bent shaft, or worn gears, right? So whenever you go for a vibration monitoring, and if you figure out there is a high amount of vibration, so this could be the problems, right? This could be the problems in the system. Okay, so that we need to figure out. So now, before going into the again that vibration monitoring, I would like to go over some introduction part of the maintenance. Okay, maintenance, it is about the condition based monitoring. Okay, it is about condition based monitoring, where this vibration monitoring is like it plays a major role. Okay, so before going into that condition based monitoring, let's see what is maintenance. Okay, so all actions necessary for retaining an item or restoring it, okay, to a serviceable condition. So it may include like just a simple servicing, repairing, or we need to modify the machine. Okay, we may need to overhaul, means open the machine, inspect, and condition verification. Okay, so this is what the maintenance is. Okay, so because of maintenance, what will happen? We can increase the availability of a system, keep systems equipment in working order, minimize production loss, and increase reliability of the operating system. Okay, so these are the like few of the benefits of performing maintenance. Okay, and again there are like different types of maintenance. Okay, so if we broadly classify, so that there are like planned maintenance and unplanned maintenance. There are like two types of maintenance, planned and unplanned. So what is planned maintenance? So planned maintenance, it is carried out. It is carried out before the failure of a equipment. Okay, so it's maintenance described as the maintenance of equipment or system before fault occurs. Okay, so how we can figure out like there will be a fault, or how we will figure out like we need to go for the maintenance. Okay, so that all comes under this planned maintenance. Okay, and all this thing depends upon the past experience or the current equipment condition. Okay, and other type, that is unplanned maintenance. Okay, so it can be described as the maintenance that like we are carrying out after the equipment fails. Okay, and if we take an example, okay, so in plant maintenance, whenever like you purchase new vehicle, okay, so what we are getting like at every 2 months or 3 months, right, we are getting our vehicle serviced. Okay, so that is what, that's a plant maintenance. Still there is nothing in the vehicle, right, there is no problem in a vehicle, but still we are getting it repaired. Okay, so that's like all that we can consider as a plant maintenance. Okay, but after let's say some time, let's say 3-4 years, when we'll go for the maintenance, let's say some of the drivers, they may go for a maintenance at every 6 months. Okay, but that is again not the case with everyone, right? Not everyone go for a service of a vehicle at 6 months. But let's say you are driving a vehicle, you notice like there is some unusual noise in a vehicle. So in that case, you will go for the maintenance, right? So again, that is planned maintenance. Still, vehicle has not stopped working, right? It is working, but you come to know like there might be some problem in the system. Okay, so you have predicted. Okay, so that's again a type of maintenance. Okay, so it's a planned maintenance, and it is conducted to keep equipment working or extend the life of the equipment. Okay, so why we perform planned maintenance? So it is to keep our equipment working or extend the life of the equipment. And why we go for unplanned maintenance? The main purpose is to get the equipment working. That's it. Okay, it's the purpose is not to extend the life or something like that. It is just to get equipment working again. Okay, as soon as possible. Okay, so in unplanned maintenance, we can consider our, let's say, in wheel. Okay, there is a puncture in a tire. Okay, so that's a unplanned maintenance. Okay, because that we won't be able to notice the puncture before there is like the tires are flat, right? So that comes under this unplanned maintenance. Okay, now what are the different types of maintenance? So it's like corrective or breakdown. Okay, so when system breaks down, it stops working. Okay, so we go for breakdown maintenance. Then we have one opportunistic maintenance, means let's say in a workshop we have like four machines which are dependent on each other. Okay, so if one particular machine breaks, so you have an opportunity to go for the maintenance of other machines as well. Okay, or in the same machine you can go for the maintenance of other parts as well. Okay, so you are having the opportunity. So that's a opportunistic maintenance or a routine maintenance. Okay, so like in vehicle again, at every 10,000 kilometers we need to change engine oil. Okay, so that's a routine maintenance. Or in machine we need to apply grease at a regular interval, right? Then we have this preventive maintenance. Okay, preventive maintenance means it again depends upon the, like, to prevent a failure. Okay, to prevent a failure we are going for the maintenance. Okay, so there is, okay, so there is some small difference between this preventive and predictive. Okay, but both these maintenance, they are planned maintenance. Okay, both these maintenance, they are planned maintenance. Okay, and the next last one, that is a predictive or condition based maintenance. Okay, predictive or condition based maintenance. Okay, so now in condition based maintenance, what we are doing, we are checking the condition of the system. It may be a continuous monitoring or it may be at a regular interval. Okay, it may be at a regular interval or it may be at a continuous monitoring. Okay, again in the case of vehicle, if there is a puncture, okay, so what we'll do, we won't be able to know until there is the tires are flat, right? So once the tire is flat, what you need to do, you need to pull over your vehicle, you need to change the tire, and then only you can go. Okay, instead of that, what we can do, we can put pressure sensors in a tire, and you have the reading of pressure of each tire on your dashboard, right? So as if there is a reduction in a pressure, okay, if there is like a pressure goes below particular level, okay, so it will give you an indication like there is a some problem, the pressure in this particular tire is below the critical level. Okay, so in that case, what you can do, you can drive your vehicle to the nearest shop and you can get it checked by the person, right? So still system is working, you are able to get your vehicle to the person, right? So this is a condition based maintenance. So what we are doing, we are continuously checking the um, parameters. Okay, and it again depends upon the system, like what parameter we are checking. Okay, so based on the system, it may be a temperature, it may be a pressure, it may be a vibration. Okay, so now if we consider the condition based monitoring, that is CBM. Okay, so few of the examples, like unusual sound coming out of a rotating equipment predicts a trouble, right? So if particular system, it starts, uh, it is rotating, and but if causes like unusual sound, so you can predict there is some problem in the system. Okay, but whenever it starts, sound started coming, means it's a, again it's already a critical situation. Okay, it's already a critical situation. Okay, so but to avoid these all this critical situation, what we are doing, we are using sensors now. Okay, nowadays what we are doing, we are using sensors. Okay, and if you see the sensors, they are like now price is quite low. They are so economical that like you can put n number of different sensors. Okay, even in your mobile, right? There are like n number of different sensors available. Okay, it's like a proximity sensors or a gyroscope or a different sensors, right? We have in our mobile. Okay, or so an excessive hot electric cable predicts a trouble, or a simple hand touch can point out many unusual equipment conditions and thus predicts a trouble, right? So there are like different ways of predicting the working condition. Okay, so but if it is internal parts, we cannot like see, we cannot touch it, right? If it's like very high temperature, you cannot predict it just by even like you cannot touch it, right? So in that case we need to install sensors, right? So here, what is the workflow? So it's, we will determine the conditional standards, means we will figure out what are the different parameters we want to figure out or we want to track, we want to monitor. Okay, so they implement monitoring tools and processes. So if it is a temperature, we will install temperature sensor. If it is a pressure sensor. Okay, create triggers for standard failures, means at what time, if let's say pressure is goes beyond, let's say 200 degree, you want a alarm. Okay, so that the type of standards failure, the triggers we want to set up, collect and monitor the data, and create work order when trigger condition met. So if temperature goes above 200 degree, you will have a trigger. You need to perform the maintenance. You need to check the system and continuously collect the data, right? So this works in a cycle. If it is everything is fine, then it's okay. If there is a trigger, we need to perform the maintenance, and it's a cycle. Okay, so now condition monitoring. Okay, so now here we are moving towards now monitoring. Okay, so it's a condition monitoring, means again we have different types of monitorings, right? So it's a vibration analysis or a thermography or a noise analysis, acoustic emission or a voltage or a current monitoring, oil analysis. Okay, so this oil analysis, it is also like very major method, important method of condition monitoring, because whenever you check the oil condition, and if there are like metal particles, so it indicates the wear in the system. Okay, so this particular method is also used extensively. Okay, but what we are now today concentrating on this vibration analysis, right? So it's a condition monitoring, it is a measuring of specific equipment parameters. Okay, so these are like different parameters. Okay, again in vibration there are like different parameters we measure. Okay, whenever we are measuring the vibration, means what we are measuring, we are either measuring the displacement or velocity or acceleration. Okay, so whenever we measure the vibration or whenever we monitor vibration, so what we are measuring, we are measuring either displacement or velocity or acceleration. Okay, so and nowadays, okay, you all must have heard about Internet of Things, right? You must have heard about this Internet of Things, or now the new word is coming up, that is Industrial Internet of Things or Industry 4.0, right? So in that case, what we are doing, we are connecting our system with the internet, right? We are connecting our system with the internet, and we can even control the system from remote locations. Okay, our machine is in let's say our machine is in Vadodara, and we are sitting in some different location. Okay, but still we are able to check the condition of the machine, like what are the different parameters of the machine. Okay, so that we are able to figure out. If you want, you can even control the machine from the remote location. Okay, so yeah, what we are doing, we are continuously monitoring the condition of the equipment and taking note of any irregularity, and maintenance or other preventive actions can be scheduled based on the condition. Okay, and condition monitoring is a big component of a predictive maintenance, right? And data collected provides current and historic state of the equipment, and based on that we can figure out what future state will be or what should be the future action. So now if you see here, out of all the different uh, condition monitoring techniques, okay, if you see 45%, okay, it is based on the vibration analysis or it is vibration monitoring. Okay, so the most of the cases, if you see, it is based on the vibration analysis, because that is the major part or it's a major factor behind the failure of a equipment. Okay, so now we are going over the vibration monitoring. Okay, so why we are going for a vibration monitoring? Because vibration, it can lead to excessive deflection and failure of a machine. Okay, to reduce the vibration through proper design and machine utilize profitability in several consumer and industrial applications, to improve the efficiency of certain machines, create excessive noise, okay, leads to poor surface finish. Okay, so when there is a vibration in the system, okay, when there is a vibration in the system, okay, if it is and in a, let's say, any machine, it's a, let's say, metal cutting process is going on. Okay, so in that case the surface finish what you will get, it won't be good. Okay, so apart from that we may have the resonance again, like we have seen one video at the starting, right? What could be the effect of that resonance? So and so these are like few of the reasons behind vibration monitoring. Okay, so now we are going over one small example of vibration monitoring. Okay, so here we have one fan. Okay, and we are with the proximity sensor. Here we have a proximity sensor. We are figuring out its motion. Okay, so if you see here, it is in 1 second we have 1, 2, 3, 4 and 5 oscillations, right? In 1 second we have 5 oscillations, means fan is rotating 5 times in a second. Okay, means 300 times 300 rpm, it is rotating at 300 rpm. Okay, now here what we have done, we have attached one unbalanced mass. Okay, this is like we have done. Okay, so here on the blade we have attached one unbalanced mass. Okay, and because of that now we have this oscillation in the system. Okay, these are the vibrations occurred in the system. Okay, so this is the vibration because of this unbalanced mass. This vibration is because of this unbalanced mass. Okay, so now this right now we are tracking this unbalance in the system. Okay, now next what we have done, if we increase the speed of a fan, okay, so here it is, the frequency is now 10, and if you see the amplitude here, what is the amplitude? Here it is 5, the amplitude is same. Okay, the amplitude of vibration is same, but now we have just increased the speed. So here it is now 10 oscillations in 1 second, means the speed is now 600 rpm. Now furthermore, now what we have here, can you see here, now we have added one rub means it is causing the vibration. It is the disturbance in the system that what we have added. Now what will be the frequency of this rub? So if this fan is rotating how many times? It is 10 times. It is rotating how many? 10 times. Okay. So its frequency of this fan is 10 hertz. It's 10 hertz. Okay. But now this particular rub, it will be rubbed along all these 8 blades, right? It will rub along all these 8 blades. Means the frequency of this rub will be how much? 10 into 8. 10 is what? Number of oscillation, or the number of rotation of this blade. So that is 10. And what is 8? 8 means number of blades. Okay, so that is 8. It's 10 into 8 means 80 hertz. The frequency of this rub is how much? 80 hertz. It's 8 times more than the fan speed. Is this fan completes its one oscillation? As fan rotates, it completes its one oscillation. Meanwhile, this rub completes 8 oscillations. Okay, so in 10 oscillations, it completes its 80 oscillations. Okay, but the magnitude is quite small, and that is that you can see here in the graph, right? So this all those disturbances, those are because of this rub. Okay, so now whenever you are like getting this smooth curve, so you can say yes, the system is working perfectly fine. Okay, because this is like additional mass we have attached and we have added it intentionally, right? So that is a normal system. So there will be some unbalanced force, so that is fine. But if you see here, it's like now the graph, it's not smooth. Okay, there is some additional vibration in the system. Okay, so that indicates towards the additional vibration in the system. Okay, so that shows there is some additional vibration in the system. Okay, now whenever you go for in the industry, okay, they want look for this type of graphs. Okay, they want look for this type of graphs, but what they will have, that it will be in the frequency domain. Okay, it will be a frequency curve. Means at 5 hertz or 10 hertz, what is the amplitude? Okay, because it's a cycle, it's right, it is continuously going over. So what is the amplitude at 10 hertz? So this is the amplitude, right? It's 6 at 6.5 or something. So that is the magnitude we have here at 10 hertz. For this particular graph, what is the frequency? So it's a 5 hertz. So at 5 hertz, what is the magnitude? So it's a 5. Magnitude is 5 units. Okay, so this type of graph is to be drawn. Okay, so now if you see here at 10 hertz, we have one magnitude that is here, and for the rub, what is the frequency? It is 80 hertz, and for that, what is the magnitude that we need to put in, right? So depending upon the type, like external factors, we may have 3, 4, 5 different frequencies and different magnitudes. Okay, so okay, and whenever we have like low frequency vibrations, they are not that much dangerous compared to when we have like very high frequency vibrations. Okay. So here if you see in the same system, okay, so on February 25th we had one, this is like normal frequency, right? At 5 or 10 hertz we have this normal vibration, but at high frequency there was like one small vibration spike, right? That was on February 25th. After around 20 days, there was the vibration spike. If you see, the amplitude has increased here, right? The frequency at a high frequency, the amplitude has increased. And again, after around 40 days, you see the magnitude. It is like now very substantial, right? So with time, the vibration amplitude will increase. Okay, so if you are able to figure out the vibration at this particular level itself, right? So just by oiling or just by putting some grease, you can put the system back to its working condition. But at this particular time, the system might have some wear and tear, so you might need to change the entire shaft. You may need to change the bearings, right? So if you are able to figure out vibration at early stage, just by oiling or just by applying some grease or just by putting shafts at some proper alignment, okay, or just by doing some balancing work, the system will be perfectly fine, right? So the cost of the maintenance will be very less, but at this particular point you may need to change the entire shaft or you may need to change the bearings, right? So at the time the maintenance cost will be very high. Okay, and this is the reason behind going over vibration monitoring, right? Okay, so I will just quickly go over like what are the different vibration measuring instruments we have. Okay, so as I just said, okay, so the classification, if you see, it is like based on contact and non-contact type, or active and passive. Okay, it's a contact and non-contact type. So if you see, this is like contact type. It's a tachometer. We all must have used this, right? So it's, we need to put it in the contact, but nowadays we have like infrared equipments, okay, which measures. We don't need to put it in the contact with the system. Or if you have heard about stroboscope, right? It works on the principle of flickering light. Okay, so this is like contact or non-contact type, or we have like active and passive instruments, means based on the power source. If it uses the external power source, it's a active instrument. If doesn't use the external power source, it's passive instrument. Or indicating type or recording type. Okay, some of the measuring instruments just indicate the vibration. Okay, it won't give you the value or it won't record the value, whereas other type that will record the whole data. Okay, so those are like few of some of the like classification of vibration measuring instrument. And we have like three main type of vibration measuring instruments. So vibrometer, so which measures the displacement. Then we have velometer that measures the velocity, and third one, that is accelerometer, so that measures the acceleration. Okay, so whenever we are working at a low frequency, okay, at a low frequency, so in that case we can go for vibrometer or velometer. Okay, in that case what we can consider, it's let's say the vibrations of in the building. Okay, vibration in the building. Okay, so the building, it won't vibrate at a high frequency, it will vibrate like very slowly, right? So that is, in that case we can go for a vibrometer or velometer. But whenever it's like high frequency vibrations, we need to go for accelerometer, because for high frequency this displacement or velocity readings, they won't be accurate. Okay, in that case we need to go for accelerometer. Okay. And these are like few of the vibrometer. Okay, and the sensors now, they are like very handy sensors we have. We just need to put this sensor, this knob on the system, and we will be able to get the displacement of a system. Okay, and most of the sensors, they work on this piezoelectric principle. Okay, piezoelectric principle means if you see this outside body that comes into the contact with the vibrating body. At the inside, we have the another additional mass, and in between these two masses, we have the piezoelectric material. Okay, so based on the pressure exerted on this piezoelectric material, it will generate some voltage. Okay, and that voltage we need to convert into the either acceleration or velocity or displacement. Okay, so this is like um, principle of this vibration measuring instrument. Apart from that, we also have electromagnetic or a piezoelectric or seismic accelerometers. Okay, so, and again that depends upon the application. Okay, because if you are working in a electric situation in the on the equipment where you have like very high current, so in that case you cannot use this electromagnetic type accelerometer, because that current of the system and the current of this electromagnetic accelerometer, okay, they will coincide. Okay, so it depends again what type of system you are using or you are working with. And another type, that is like velometer. So again it is to measure the velocity, and they are again active or passive type velometers, that what we have. Okay, so yes, that's it from my side. Now if you have any doubt,
Thank you, sir. Thank you, Tejas, sir.
thank you.
We will go ahead and take some time for the question now. Just a reminder.
No,
Be
I'm not
sure.
able to hear clearly, અંકિત સર. અવાજ ક્લિયર નથી આવતો.
You are audible now?
આવે છે. યસ, બોલો બોલો.
Yes. Thank you, Tejas, sir. We will go ahead and take some time for the question now.
Okay.
Just a reminder, please be sure 78225259. Tejas, sir, there is one question from one of the students. What is the force vibration?
What's the question?
Force vibration. What is the force vibration?
Post vibration.
Force vibration, sir.
Sir, can you type it?
Yes, sir.
Okay, force vibration means whenever we have like force continuously exerted on a system. Okay, just a minute. If we even see this particular figure, spring mass system we have seen, right? In that case, there will be a continuous force exerted on a car, right? Here, there will be a continuous force exerted on the system. So that's a forced vibration. But in case of simple pendulum, there is no continuous force we are applying, right? So that's a free vibration, right? So whenever a continuous force exerted on the system, it's a forced vibration.
I'll send the second question also, sir. What precautions are to be taken when installing a vibration measuring instrument?
Okay, so first of all, where you want to measure the vibration. Okay, so that is a very critical thing, right? So where you want to uh, measure the vibration. So first of all, to identify the place where you want to figure out or measure the vibration, that is the first thing. Second one, how critical, okay, how critical it is to measure the vibration, because we have like different types of sensors. Like what is the accuracy or what is the precision of the sensor. Okay, so that is the second thing that what we need to figure out. And then again I said what type of sensor to be used. Okay, it again depends upon the working condition. So as I just said, right, in wherever like you are working on electric system where you have high current, so in that case we cannot use that electromagnetic sensors, right? So these are the like few of the things we can consider while installing or even like selecting the sensors.
Okay. Thank you very much, sir, for sparing our valuable time, and thank you, everyone. We appreciate you being here, and I would like to present an appreciation certificate on behalf of Paril University.
Okay, thank you sir.
Just a minute, sir. So we will be having our next webinar scheduled on next week. So please guys join us for the same, and we will update you for the same and time also. Thank you again for joining us today, and we will see you next time. Have a good day. Thank you very much, sir.
Thank you. Have a good day.
Thank you, sir.